All right. So with face values, you've got 10 different face values, 10 different pictures. That's the what. The place values are where. So this 2 and this 2 both have the same place value. So on a test, I might say, what's the face value of the underlying digit? I expect you to write the word 2. But if I say, what's the place value of the underlying digit? What place value is the 2 in right there? The hundreds. What's the place value of that 2? The tens. The value is the product of the 2. So that 2 isn't just a 2. Is everybody with me? It's a combination of its face value times its place value. What does that 2 really stand for right there? 200. But the 2 over here doesn't stand for 200. What does it stand for? 20. The face value times the place value. Okay? Now, the reason I tell you that is this. The Egyptians did not have place value. So it didn't matter where you drew the picture. That picture stood for the same thing all the time, whether it was in the front, in the middle, or in the back. So on page 84, do you see that funny looking scroll? It's kind of like a 9. What value did that picture have for them? 100. So look at the lotus flower, and how intricate is that? What's that stand for? 1,000. I think my favorite is always the astonished man. Okay. What does that picture stand for? 100 what? I mean, it stands for what? A million. Is everybody with me? So if they wanted to write numbers like 953, what are they going to have to do? Well, what's 100? What picture is 100? So they're going to have how many of those? 9. All right, how are they going to do a 50? Now, they can put the heel bones here. They can put some back up here. It doesn't matter. Now, they tended to draw them in order kind of from big value to small value, but it wouldn't have mattered. How am I going to get the 3? But like I said, they might have just decided, you know what, let's have some fun. You see what I'm saying? It doesn't matter where it is. Every picture's got a value, and what do you do with all those values? You just add them up. So it takes a lot longer to write a number when you don't have place value. Now, the Babylonians only had 2 pictures. What are they? That triangle and that what? Looks like a less than, doesn't it? Okay, but here's the catch. They were base 60. Now, what in the world do I mean by base 60? Here's what I mean. Let's go back up to your English system. What place is that? The ones. What place is this one? The tens. What about that one? The hundreds. What about this one? That's the thousands. And this one? 10,000s. And what's this one? 100,000s. Your number system is in base 10. Now, what do I mean by that? I'm going to erase them. Is everybody with me? When you got a number like 3 squares, everybody with me? This big number is called the base, and this little superscript is called the exponent. Now, we're going to get to decimals later. But, you know this already. When a number doesn't have a decimal, where is it understood to be? Do you know it's at the far right? So the first place to the left of the decimal, everybody with me, is 10 to the 0. So do you see that these big numbers, what are they called? They're called bases. These bases are literally what? Tens. The first exponent is a 0, it's your whole numbers. So 0 what? 1, 2, 3, 4 what? 5. Now we talked about this before. What's any number to the 0 power except 0 to the 0? It's 1. What's 10 to the first? That's just 10. What does 10 to the second mean? Does it mean 20? No. 10 to the second, it means 10 what? Times 10. Repeated multiplication is exponents. Well, what is 10 times 10? Didn't you tell me that was your hundreds column a second ago? See, what does 10 to the third mean? Well, that means you have 10 times 10 times 10. Well, you told me 10 times 10 was 100. What's 100 times 10? And didn't you tell me a second ago that that was your thousands column? If you multiply 10 by itself 4 times, you get 10,000. If you multiply 10 by itself 5 times, you get 100,000. Now, one of the things I expect you to be able to do is I'm going to ask you to write numbers in expanded form. Now, expanded form is the sum of the products of the face values and place values. So if somebody gave me this problem and said, write 236,504 in expanded form, the first thing I would do is label the places, like I've done here. Now, I've got to understand the meaning of some words. Sum of the products. What is a product? Multiplication. What is sum? It's addition. Now I want the sum of the products. Well, I can't sum something until I know what it is. So do you understand? I mean, 4 is my face value. Times, what place is that 4 in? I don't care if you put 10 to the 0. I don't care if you put 1. Is everybody with me? Your pick. But you probably better get used to these exponents because next week you'll be doing base 5. That's a product. A face value times a place value. Is everybody with me? Now, I don't care which way you go. A lot of times people go in order from big to small. It's not wrong not to, but it's got to go in order. So let's kind of go. That would be a 2 times a 10 to the what? 5th. Then I've got a 2 times a 10 to the what? 4th. Then I've got a 2 times a 10 to the 3rd. A 6. Let me do that right. It's a 3 and a 6. Everybody with me? I've got a 5 times a 10 to the what? 2nd. I've got a 0 times a 10 to the what? 1st. And I've got a 4 times a 10 to the 0. Now, does everybody understand what I mean by product? So I've got products of face values and what? Place values. Product of a face value and a place value. So I've done the products of the face values and the place values. Now, what have I got to do with those products? I've got to sum them, which means to do what? Add them. That is your answer. Now, the number's not bigger, the form is bigger. You see what I'm saying? It's an expanded form. So in every parenthesis, you have the face value. It's very obvious to the kids, and the what? The place value. Now, for you or for them, if you've got 7th graders, they probably aren't going to do those powers. Everybody with me? So instead of having them 10 to the 5th, they're probably going to put 100,000. Instead of 10 to the 4th, they're probably going to put what? 10,000, 1,000, 100, 10, and 10 to the 1, same thing as what? 1. You can do it either way. But they can at a glance tell you the place value and the what? Face value of every picture up there. Now, why I'm making a big deal about that? What we're going to do is talk about other number systems. So the Egyptians had place value. But theirs was base 60. So the bases aren't 10s. What are the bases? 60. This is still a 0 power, a 1 power, and a 2 power. Everybody with me? 3, everybody with me? Now what's 60 to the 0 the same thing as? 1. All right. What's 60 to the 1st the same thing as? That's the same thing as 60. That's my 60s column. Not my 10s, my what? My 60s. What column is this? 300. That's my 3,600s column. And they only had 2 pictures. So look what the 2 pictures were. All right, they had little bitty what looks like less than symbols. They tell you that stands for 10, and then the little triangles are a 1. So if I saw this number, I've got to know what it is. Well, what does the triangle stand for? What? A 1. What's that? So what's that right there? That's what number? 11 ones. 11 times 1. What's this number? 21 what? 60s. 21 60s. And 11 what? Ones. Everybody with me? So what's 21 60s the same thing as? All right, by hand or with a calculator, find me what 21 60s is. We get 1,260. What's 11 times 1? What number is that? 1,200 what? Now, the thing to me that's hard about Egyptians is I don't know where the break is. You see what I'm saying? Do these 3 go together and those 2 go together? Or do they, you see what I'm saying? It's hard. You know, if there's not some space there, I don't know what pictures go together. Now, people will say, well, that's the dumbest thing I've ever heard. You use Babylonian every day. What do we still use that's based on 60s? Time. Time's Babylonian. There's 60 seconds in a what? Minute. There's 60 minutes in a what? Why? Because it's Babylonian. So there are other bases. So next week, when we start playing with base 5, everybody with me? Now, what's interesting is this, because you're not going to ever teach base 5. You're going to teach base what? 10. But if you don't understand base 5, that tells me you don't understand base 10, which means you're not going to be able to teach it. And I can figure out very quickly if you really understand base 10 by how much you understand base 5. So you're going to have to add and subtract numbers in base 5 and talk about bundling and unbundling, because you're going to have to teach adding and subtracting in base 10 with bundling and unbundling. So this idea of write down the right digit and carry the left digit is not going to work. And that's not the way you teach base 10. If you do, it's going to hurt them later. So if you do it correctly, decimals and fractions will be easy for them. If you do it wrong, you're going to make their life infinitely harder. So I know you know how to add 23 and 45, but a lot of you don't know why you do what you do. And if you don't understand the whys of it, you're not going to be able to teach it. Okay? And if I stay in base 10, you'll do your little shortcut tricks. And they're not going to help you when you go to teach it. So I've got to get you out of base 10 and put you in another base. Now in base 10, it seems easy to you. You don't understand why a first grader is struggling, but you will when I put you in base 5. Because see, in base 10, every time you get 10 of something, you trade it. When you get 10 ones, you trade that for 1 10. When you get 10 tens, you trade that for a what? For 100. When you get 10 hundreds, you trade it for 1,000. So in base 10, you group things in groups of 10. Well, see, when we go to base 5 next week, you're going to group things not in 10s anymore, but in what? 5s. Every time you get 5 of something, you're going to trade it. So that's the reason for shifting you, but I want you to understand there are lots of other number systems here besides the one that you're familiar with. Now, the only one I'm going to hold you responsible for on a test is a number system that's still used, and that is Roman numerals. Okay? So I'm not going to test you on Mayans, I'm not going to test you on Babylonian, I'm not going to test you on Egyptian, but I do want you to know they exist. So when they go back and do archaeology, start digging stuff up, and they run across dates and scrolls with calculations and things, they've got to be able to decipher those. Now, but Roman numerals are still in America, several different places, so we got to make sure we know them. Okay, now, you've got to know the values of the pictures. So if you know them, great. If you don't, they're on page 86. So when you see like an I, sometimes people get lazy and put a tally mark. What's that picture stand for? A 1. What's a V? 5. You know what a 10 is? It's an X. Now this one, a lot of people don't know. You know what an L is? It's 50. All right. What's 100? C, isn't it? What's a D? 500. What's an M? 1,000. Now, Roman numerals don't have place values. Wherever you see an M, what does it stand for? 1,000. No matter where that V is, what does it stand for? 5. So they're in your books on page 86. But now here's what is true. So when you are changing from Roman numerals to, let me see how your book phrases it, and I'll phrase it the same way. I know what I would say. raise it anyway. All right. You can do everything. Sometimes I'll call it just a standard numeral. The first thing you better do is you better write the value of each item. Right. Write the value of each letter, each item. Okay. If the values are in order from big to small, you simply add. Okay. If, however, you have a smaller value in front of a bigger value, you replace the pair with its difference. Okay. So if you've got a smaller value in front of a larger or a bigger value, you replace the pair with their difference. And then when the values are in order from big to small, what do? You add. Now you write that down. Let me show you what I'm talking about. So I've got the Roman number written here, MMDCLXB. And I want to know what standard numeral, what Hindu Arabic numeral that represents. So my first step is I write down the value of every one of those items, every one of those letters. So what do the M stand for? All right, 1,000. All right, what's that D stand for? 500. What's that C stand for? 100. What's that L? 50. What's that X? 10. And what's that B? 5. So that's what I mean by write the value of each letter. Now, are these values in order from big to small? Yes. Then just add them. So 1,000 plus 1,000 plus 500 plus 100 plus 50 plus 10 plus 5. So what number is that? 2,000 what? 600? 1,600. Okay. We okay so far? Now, look at this one. Now, so you've got an M, a C, an M, an X, an L. Let me do this, an X, an L, and then a tally, like a 1 and a 1, like a tally mark and a tally mark, like an I and an I. Now, what's my first step? Write out the values of everything. What are the M's? They're 1,000, no matter where they are. What's the C? 100. What's the X? 10. What's that L? 50. And both of those I's are just what? Ones. Now, are they in order from big to small? No. Where do you have a small one in front of a big one? I've got 100 in front of a what? 1,000. Then I'm going to X both of those out and replace them with one number. The one number is their difference. What do they differ by? 900. So those are gone and 900 is going to replace them. Do you have any more small ones in front of big ones? The 10 and the 50. All right. So what are they going to get replaced with? What's their difference? 40. Now are my numbers in order from big to small. I've got 1,000, a 900, a 40, a 1, and a 1. So what do I do when they're in order from big to small? I should add them up. So what number is that? 1,900 what? 42. So you've got to be able to go from Roman numerals to standard numerals. So is everybody okay with that? Now let's go the other way. What if I give you a standard number and now you've got to go to a Roman numeral? We got to go from a standard numeral to a Roman numeral. Now, there's some rules. All right, here's the first rule. You cannot have more than 3 same letters in a row. Let's say of the. You can't have more than 3 of the same letter in a row. So that means if I want to write 400, I can't put 4 C's. That's not allowed. What's the most I can have in a row that are alike? 3. So how am I going to write 400 then? I'm going to have to take 100 away from what? 500. That's why sometimes you have small numbers in front of what? Big numbers. All right? The second thing is this. As a general rule, they're not going to jump over something. So in other words, when you put a smaller value in front of a larger value, they need to be kind of what us call in parentheses like next to each other or in line. I'll show you what I mean in a second. Here's what I mean. They're not going to do this. 49. Think about what's the biggest picture you know? Is it D? What's the biggest one? M. What comes next? D. Then what? C. Then what? L. X. B and I. They're not going to put a 1 in front of a 50. You see what I'm saying? They'll put a what? A 10 in front of it. You see what I'm saying? It's got to be the next one. Now, they occasionally break their own rule, but generally speaking, so if they wanted to do 49, what would I have to do? I can't put 4 X's, right? So what am I going to have to do to make the 40? Do you see what I'm saying? You have to take an X away from what? 10 away from 50. Is everybody with me? And then the other thing is this. When you're making them, generally start with the biggest picture. All right, so let's start with a simple one. 2020. How would I write the date 2020 in Roman numerals? Well, what's the biggest value in there? Aren't it into the thousands? So how am I going to write 2,000?
2 M's.
2 M's. Can I put 2 in a row?
Yes.
What's the most I can put in a row? 3. Do I have any hundreds? No. I have two 10s, don't I? How am I gonna write that? There you go. Don't I have to make 1,000? How do I make 1,000? Now I need 900. Can I put 9 C's? I can't, can I? Can I put a 500 with 400s? No. How am I going to make a 900? I have to put a what in front of a what? A lower value in front of a bigger value, right? What am I going to take away? I'm going to take away 100 from what? 1,000. So they're next to each other. All right, how am I going to make a 70? Can I put 7 X's? All right, what am I going to have to do? I can put a 50, right? And then what? 2 more 10s. Would that make me a 70? Now, can I put 4 tally marks? No, so how am I going to make a 4? Don't you take a 1 away from a what? From a 5. Now, the only time that I've ever seen them skip over, they didn't have a choice, really. The only time they allow that is the number 9. For 9, they'll take a 1 away from a 10 instead of doing this. But I think that's the only exception when you can skip the order. Okay? Now, the Super Bowl is always in Roman numerals. When you look at the end of movies, they're in Roman numerals. Buildings that have years on them are in Roman numerals. We still use Roman numerals. Okay? So you got to be able to go from Roman numeral to standard form and then standard form back to what? Roman numeral. Okay? Now, I'm not going to test you on this, but I am going to show it to you. That's what you have to do. But does everybody see a problem? How are you going to make a 5,000? Because what's the biggest picture you have? An M, right? And they don't put more than how many in a row? 3. So I'm not going to test you on this, but I do want you to understand. When you see a bar above a number, it means to multiply under it by 1,000. See, what does that V stand for? 5. That bar stands for multiply that number by what? 1,000. So do you understand that V with the bar over it stands for what? 5,000. How would I make 6,000? A VI with a what over it? A bar. Everybody okay? What number is an M with a bar over it then? What's M? What's that bar mean? Multiply by what? 1,000. What number is that? It's a million. Now, this is the one that freaks people out. They would do more than one bar sometimes. But you got to work your way up. Is everybody with me? What's that 5 stand for? I mean, that V stands for what? 5. What's that bar mean? Take that 5 and what? Multiply by what? 1,000. Isn't that what's under that bar? So I've got to take this and multiply by another what? 1,000. It doesn't mean 5 times 2,000. You see what I'm saying? So you understand that this is 5 million. Okay, I'm not going to test you on the bars, but I'm going to test you on the up. Okay, but that's how they would handle bigger numbers. Okay, now part of your homework is a couple of things. One is you're going to have to make your base 5 blocks. Okay, another thing you're going to be doing is you're going to be writing numbers in expanded form. All right, you're also going to be playing with Roman numerals a bit. Then there's going to be a worksheet on patterns that you have to do. Okay. And by that I mean not all of them will be arithmetic or geometric. Like, what if you had a pattern like this? Now this one would be geometric. I mean, this one would be arithmetic. What am I doing every time to get the next number? I'm adding 3. Okay? Multiplying by 2. This one's arithmetic, this one is geometric. What am I doing every time? Just repeating. 2, 3, 4, what? 2, 3, 4, what? 2, 3, 4. So how'd they get from here to here? Adding 1, what about here? You with me? So on the worksheet, some are going to be super simple and some are not. Everybody with me? So you're going to play with that worksheet. And where's your homework going to be? Okay. I will see you next Thursday. I'll see you on Zoom on Tuesday. I'll see my Zoom people on class on Tuesday.